So in part 3 for module 5, we're going to do the problems 7 through 11. We're going to use one technique for this one. We're going to start off with actually two, so it's kind of out of order. So number 7, you should notice, again, there's no GCF, and that it's two terms. It's a binomial, which means if it's a binomial, we have only one choice to see if it's a difference of squares. So when I look at this problem, I ask myself, can I rewrite it with two squares with a minus, a difference between them? And so in this case I can. That would be p quantity squared minus 7q quantity squared. So that's going to give me my difference of squares. So p plus 7q, p minus 7q. Doesn't matter the order that you write them in. You can write one with a plus and one with a minus. Again, you can FOIL it out to check it. This is one of the easiest ones on your test. Please make sure you know your difference of squares. Going to number 8, again, this is a trinomial. And so we look at this, we should first say, is there a GCF? And we look across and there's no GCF. Leading coefficient's not a 1, so that's kind of leading us into the next sections. But what I want you to notice, again, we still start with our signs. So this means that they're going to both be negative. But if you notice that the first term is a perfect square, it's not always going to work. I want you to always look, is the last term a perfect square? If you notice the first and the last are perfect squares, I want you to guess and check that. So that would be 6x minus, because my signs match, and 49 would be 7. So I'm going to check it by FOILing it. That gives me 36x squared minus 42x minus 42x plus 49. When I add these two together, I get the minus 84x, which is correct. There are two ways you can write your answer. You can write your answer as 6x minus 7 times 6x minus 7, which is perfectly acceptable. When you watch her videos, she's going to show you a shortcut, and she's going to write it as a quantity squared. That's absolutely okay as well, but I need you to make sure you're careful. These are different ideas. Plus and a minus means a difference of squares, and there's no middle term, so you have a binomial. If you have a quantity squared, you have to FOIL it out, and you do get that middle term. So now we're going to go to Module 5, dealing with trinomials where the leading coefficient's not a 1, and we're going to do this two different ways. So the first way we're going to do it is still trial and error, which is again the preferred technique. So when we do trial and error, we're still going to start it with the same idea. First question is, do you have a GCF? We look across, there's no GCF. Next step, look at your sign. If it's a positive, it matches the middle sign, so they're both positive. So trial and error for these problems, you do have to FOIL it out to make sure it works. So I'm going to start off, put my signs, and the next thing I want you to do is know that when we're doing trial and error, we are making this work for the first and last term, and we are going to check to see if it works for the middle term. So the first question I want you to ask yourself is, either one of those numbers that I highlighted a prime number, which means I can only do 1 times the number itself when I factor it. 6 is not prime, but 2 is. So anytime you have a prime number, I want you to go ahead and put it down, because that's done. You have no other choices for that, so we're going to leave that one alone. I'm now going to write down my choices for the number 6. So I have 1 times 6, 6 times 1, 2 times 3, and 3 times 2. Doesn't matter the order I write them in, but I have 4 trials of being able to rotate those. But you do have a shortcut here. Because we've already checked that there's no GCF, I want you just to listen to this. I don't want you to write it down. If I use if I use the first one, which is x, which would be 1x, and 6x, we should automatically, before we even try to multiply it out, this has a GCF. It cannot have a GCF, so that one is gone. Similar idea, if I wrote down the last one, which is a 3x and a 2x, this would have a GCF. It cannot have a GCF because we decided in the beginning, and that's why it's really important that you do try it in the beginning. So that one doesn't work. So with this trial and error, we actually only have 2 trials that we need to try. So I'm going to start off with the first one that I have listed. I'm going to put a 6x and a 1x. And again, some of y'all will get quicker at this. So I FOIL this out. This gives me 6x squared plus 12x plus 1x plus 2. Remember, we designed it to work for the first and last. We're checking, does it work for the middle? I got 13x. I wanted 7x. So this one does not work. So I can cross that one off. So I'm going to set it up again with the plus 1 and the plus 2. What I say is, yes, you can erase it, but at least keep a list of what you've tried. So my last possible piece is going to be a 2x and a 3x. If I FOIL this one out, I get a 6x squared plus 4x plus 3x plus 2. Add the like terms, it gives me the 7x. Remember, the design was, it worked already for the first, it worked for the second. We are making sure it works for that middle term. So my correct answer for this problem is 2x plus 1 times 3x plus 2. Again, there are many other ways. Again, she's going to explain it slightly different, but I always will suggest starting with your prime number first, put that down, and then cross out anything that would have a GCF in it. That eliminates some of the trials. So we're going to now move on to number 10. And we start again with looking at number 10, 3x squared minus 17xy minus 6y squared, and ask ourselves, is there any GCF across the board? Always check that. There's not, so we're going to use that. So now we look across again and decide what our signs are going to be. Because it's a negative, it means I have a positive and a negative sign. So I already know right now that I have a positive and negative. Now I may have to flip those signs. So we're now going to look at what we're designing it to match. We're designing it to match the 3x squared and the 6y squared. We ask ourselves, are either one of those prime? The 3x and the x are prime because 3 times 1 is my only choice. So I'm going to write over here my numbers for my 6. 1 times 6, 6 times 1, 2 times 3, 3 times 2. If I use the second one here and I put a 6 in this first parentheses, that can't work because I have a GCF from the first parentheses. So that one is gone. Also, I can't put a 3 here because that would create a GCF, so that last option is gone as well. So again, I've eliminated it down to 2 trials. Some of you will get to the point again with these trials that you're quicker in being able to look at which one to try first, but now at least I've narrowed it down to 2. So I put my 1, be careful, there's a y, don't forget that piece. We would catch that by foiling it out. So I'm going to FOIL this out, it gives me 3x squared minus 18xy plus xy, because remember we put in alphabetical order, minus 6y squared. That gives me the negative 17xy. That actually matches. That's my goal. It matches. So my final answer here is 3x plus y times x minus 6y. If you put a 1 in front, it's not going to mark it wrong. Other quick comment, if you had had the signs flip-flopped in this one, when you FOILed it out, you would have gotten a positive 17xy. So if that ever happens when you have a negative and a positive, it just means change the sign. Leave everything else alone. So last example here, using the trial and error method. Again, GCF, there isn't one. Scan it. My signs will be opposite signs. Look at my 2 numbers. Now, if there isn't a prime number, it just means you're going to have a lot more trials to do. So that's sometimes where I will tell you that you have a choice of which technique to use. That's when I probably would use the AC method. But this one has the number 3, which is prime again. So I'm going to put my 1 and 3 down. And right now, again, I don't know, but I'm going to put a positive and a negative. My signs are opposite. The number 4 has 1 times 4, 4 times 1, and 2 times 2. Those are my choices. If I scan this, none of these will create a GCF, so I can't cross any of them off. So again, I'm just going to start with the first one I have listed, which would be 1x and a 4x. So I'm going to FOIL this one out. 4x squared minus 3x, multiply my inner, plus 4x minus 3. Remember, we designed it to work for the first and the last. We're checking the middle. That gives me a positive 1x. That is not my piece that I want it to be, so I'm going to cross this one out. This one doesn't work. So I'm going to start over with my parentheses. Put my plus 1 and my minus 3 there. I'm going to now go to the 4x and the x, which is my second trial in my list. It's going to give me 4x squared minus 12x plus 1x minus 3. In this case, this gives me a negative 11x. That again does not work because I needed a 4x. So I'm going to cross that one out. So I have one more trial to make. Start with what I have. Sorry, let's change that sign to the sign that I have. I'm going to use the 2x squared. Sorry, the 2x and the 2x. That gives me 4x squared minus 6x plus 2x minus 3. When I add these middle terms together, notice it's super close. I have a minus 4x, but I want a positive 4x. You do not need to retry this. If you have an opposite signs, what that means is take what you got for your answer and change the signs. So basically flip-flop your two signs. That is actually the correct answer. But again, if I want to double check on the test, all I do is FOIL out. So give me a positive 6x and a minus 2x, which would give me the positive 4x. Every problem on your test is going to be factorable, at least a GCF. So in your homework, it may pop up that there's something prime, but on the test, everything will be factorable.